Hello and welcome back, ladies and gentlemen, to another lesson on stoichiometry. This is kind of where it's all been leading up to, these types of calculations, these multiple step calculations. This is kind of the culmination of a lot of our work, being able to do these types of problems. So let's get started. So stoichiometric calculations. We have our first problem here is sodium metal burns in air according to the balance reaction shown below. We have 4 sodium plus O2 gas makes 2 Na2O gas. Okay. Now the question is how many moles of oxygen? Right, so we want to know how many moles of oxygen are needed to completely react with 9.5 grams of sodium. Okay, so this is the thing that we want, and this is the thing that we have. So we have to get from here to here. Okay, so this is really nice because it kind of gives us a template that we want to work from here down below. And on your document, let me pull that up really quickly. Your document will have these yellow boxes for you to type in your answers. Okay, so for this first one, you can just follow along with me. And then for the next ones, you will be doing the calculations yourself. And back here. So how many moles of oxygen are needed to completely react with 9.5 grams of sodium? So if we have 9.5 grams of sodium, that's where we're starting. So we're going to write that right here. 9.5 grams of sodium. Okay, 9.5 grams of sodium. Now, how do we get from grams of sodium to moles of sodium? Because remember, here, everything is tracked in moles, right? And so what we do is we use this next conversion factor here, right? This one right here. 1 mole of sodium per however many grams of sodium is in a mole. Now, if you look it up on the periodic table of elements, the numbers of grams of sodium that are in 1 mole would be, this is going to be hard to write in this small space, but it's going to be 22.99 grams of sodium per 1 mole, right? So that's our conversion factor. This, right, we've done several videos ago, so you can go back and check out those different gram to mole conversions. I believe the video was called gram to mole conversions. The computer's running a little slow today, I don't know why. So over here. Now, the way that this works is we kind of just leave these numbers here and we kind of just keep going with it, right, until we get to our answer. It may not seem like a lot of sense right now, like why wouldn't I just calculate this first? The reason why we do this is because we were letting the units guide our work, right? So we started with grams. Grams is in the bottom of this conversion factor. What that's going to do is that's going to cancel these grams here, right? Because what do we actually want? We want moles of oxygen, right? So we're going to write everything out and then we're going to calculate it later. So 9.5 times this conversion factor. Now what we have to do here is we want to change from the moles of sodium that we have to moles of oxygen. And how do we do that? Remember, we use this equation, right? We have 1 mole of oxygen here, and we have 4 moles of sodium here. And so we're going to plug that into our next conversion factor. 1 mole of oxygen and 4 moles of sodium, right? And then once you plug all this into a calculator, right, then you're going to get your answer here. Because that's going to give us, right, because these moles of sodium are going to cancel with these moles of sodium, right? My old chemistry teacher in college used to say this quote, "Let the units be your guide." Oops. Let the units be your guide. So if you're unsure of where to go next, right, in these types of calculations, where did you start? Where do you need to end up, and how are you going to get there? Usually you're going to have a gram to mole conversion, and you're also going to have one of these molar conversions that comes from this equation here. Okay? Now, let's plug all of this into a calculator. So 9.5, remember, big number down here, so we're going to divide. So 9.5 divided by 22.99. Then, right, another conversion factor. Again, big number on bottom here, so this time we're going to divide again by 4. And if you plug all of that into a calculator, we're going to get this, right? 0.103 moles of oxygen, okay? So I'm just going to round that up. Let's just round it up to the nearest 100ths. So we'll do, our final answer will be in red. Oops. That would be 0.10, right? Up to the nearest 100ths place, so we drop the last 3 there. Moles of oxygen. Okay? Now, if that was a little bit mysterious, right, I encourage you to look at this again, go back and play the video again. So we're just starting with these units, canceling out those units with a conversion factor we know, right, changing from grams to moles, and then again starting with a conversion factor we know, converting from one mole thing to another mole thing, and then getting out our answer. If we look at the next 2 pieces here, right, that you will have to do, how many grams of sodium are needed to produce 12.5 grams of sodium oxide? So sodium oxide, right? Sodium oxide is here, and then sodium is here. Okay, so we have what we started with, 12.5 grams of sodium oxide, and then we have our first conversion factor, right? Again, how many grams of sodium oxide are in 1 mole? Remember, you get this from the periodic table. Remember that video? And then we have our next conversion factor. Has not been given to you, right? You're going to get this from this equation. How many moles of sodium, I know that's poorly written out, how many moles of sodium are in how many moles of Na2O, right? Na2O, sodium, you guys can figure this out. And then the last conversion factor here is grams of sodium in 1 mole of sodium, right? And so that, again, is going to be from the periodic table. And again, let the units be your guide, right? So you're going to, once you figure out this one, right? When you get down to this problem, right, there's nothing here for you, right? You're going to have to do all these calculations yourself. What you want to start with, right, is, right, what you know, or what is given, 2u. And then, right, you're going to have some conversion factors. You might have 1 or 2 conversion factors in order to cancel out the units to get to where you want to be, right, which is the answer in whatever units it's in. Now for this one, it's how many grams of water can form this many grams of acetylene, right, when it's burned. If this much is burned. So you start here, right? This is step 1, and then this is your final step. This is the answer, right? Grams of water. So you should be putting grams of water over here, right? Over here, this is your grams of acetylene. Acetylene is this one, C2H2. C2H2. Okay? I hope that's helpful. Again, if you got a little bit lost, stuck, or confused in there, go back and rewatch the video. Just go ahead and type your answers into this document. It's attached. Oops, sorry. It's attached to the lesson. It's attached to the lesson here. Type your answers in those boxes, and then remember to click submit. And I hope you guys have a fantastical, magical Wednesday. Bye-bye.